Dudes, the first step to solving any physics problem is to draw a picture. Yes. So we're going to draw a picture. This is our elevator problem. So we're going to draw an elevator with a person in it. Here we go. Oops. Elevator with a person in it. Little scale. Little man. Okay. Mass of the man is 75 kilograms, right? Is that what it is in problem 3? Mass is 75 kilograms. Okay. So when we draw these pictures, do we have to include all the forces? We do. So what's holding up the elevator, Greenie? Cables. Do cables have tension on them? So you have to write force tension. Ft. Does the person have weight? Mass. Okay, we're going to assume that, Logan, this is a massless elevator. It's a magical massless elevator, and only the person has the mass. Okay, but the floor of the scale that he's standing on is pushing on his feet. Okay, so write negative force of gravity. That's weight. Remember, Fg means weight, right? Right. Why is it negative? Because gravity. Now, number A says the elevator moves upward at constant speed. What did we just say about constant speed when we just did these spring scale things? What kind of force do you have at constant? What kind of net force is there at constant speed? 0 net force. Well, what is the net force composed of? All of them that you see. Okay? All that equals net force. So if we write net force equals our force of tension plus negative force of gravity, and net force is 0, then doesn't the tension equal the weight? It does. So did Chris Parham already solve the weight? You didn't? Did Ryan? What is it? No, buddy. Newtons. Let's solve Newtons. Okay, so my tension force is equal to my weight. We'll just solve for weight. Just solve for weight. Here we go. A negative 75 kilograms times negative 9.8 meters per second squared. I have 735 newtons. Yes, 735 newtons of tension. It's just equal to the person's weight. Go ahead and get your spring scale and hang your weight. That is exactly what's going on. I know it says moving, Logan, but it's constant motion. It's not accelerating. I just moved it. I just moved it. Oh, yeah, well, that would become negative. But I still get a positive number. Okay? No, you don't like that at all? Why not? It's moving at constant motion, just like when you're in a car and you move at 55 miles per hour at constant speed. You can talk on the cell phone, you can drink your Pepsi, you can Snapchat, and you can read text messages. But when the car accelerates, all of a sudden you have a problem, don't you? Like when you slam on the brakes, that's an acceleration. Or when you stomp on the gas, that's an acceleration. But then when you're up to speed, it's fine. Well, that's what's going on here. Yes, Ryan? Yes. It'd be the same thing. You see, what did you guys just do? You accelerated the spring scale, and then after you got done accelerating it, it went back to its weight. No, it's positive because the tension's up. All right, number B. Now it's going to slow down while moving downward. It's going to slow down while moving downward. It's going to slow down while moving downward. Where's the net acceleration pointing if it's slowing down while moving downward? What, Ryan? Yes. My net acceleration is positive, 2.0 meters per second. It's slowing down. What other forces do I have on here? I got tension again, and I got the weight. Okay? So where's the overall net force on this thing? Down or up? Up. The overall net force is up. Well, wouldn't it move up? It's slowing down. It hasn't started moving up yet. Logan, you think it's like Bugs Bunny universe where the elevator falls and then he just steps off the elevator right before crashing? You think that's real, don't you? You ever seen that in cartoons where the elevator falls and they just step off like Tom and Jerry? The most violent cartoon ever invented. All right. Net force is equal to my tension plus your weight, which is negative direction, okay? If this is the net acceleration, if we multiply the mass of the person, Greeny, times net acceleration, can we get net force? We can. We can. Okay? 75 kilograms times 2.0 meters per second squared is the tension on the cable plus the weight. Well, the weight over here is negative 735 newtons. Okay? So that's 150 newtons, right? Equals force, tension, minus 735 newtons. Oh, wait, why is it minus? Because it's down. Because it's weight. Weight is minus. Weight's always minus. Weight's always minus. Why is weight always minus? Where does weight drag you? Down. Right, Riley? Riley, move the 735 to the other side and give me the answer. Hashtag algebra. Yep. 885 newtons. Okay. So, how heavy does that person feel now? 885 newtons. And if you multiply it, yeah, huh? Oh, up. It's a squat. Yes, you can. If you have a super fast elevator, yes, you can do squats. That's correct. Yes, you'd be very strong. If you hung out on a larger planet, Alejandro, if you hung out on a larger planet with more gravity and walked upstairs every day and then came back to Earth, you would have monster quads. Okay? Does that explain Superman? Yeah. Well, if you read the Superman universe, there's more to it. Just ask James. James knows all about the Superman universe. No, we don't have time. It's a long history. Do you? No, you don't. Okay, all right. If you want to do that, Logan, I'll tell you what. I'll invite him up here, and I will give you an exam on everything that he goes over. How about that? And you guys would have physics calculations based on all the bull crap he says. Exactly. And yeah, exactly. And you'll have to calculate the drag force on all those ducts. And you'll have to calculate the heat capacity of those things. Another elevator, part C. Well, you just draw a box then. Okay, number C, it speeds up to 2 meters per second while moving downward. So which direction is the acceleration? Down 2.0 meters per second squared. Okay, that is the net acceleration. Well, it just adds to it, okay? Now, same thing. Net force is down, okay? You have tension. and you have weight. Keep it simple. When you press the button and you go down, what's it feel like on the elevator? You feel heavier or lighter? Lighter. Okay, so if that is, well, by the way, is this positive or negative acceleration? Negative because it is what? Down. So now calculate the net force. 75 kilograms, negative 2.0 meters per second squared. Tension on the cable, minus weight, 735 newtons. Okay, what's this over here, Green? It's negative 150 now. All right. Now, Riley, what's the answer? Add 735 to both sides. No, Ryan? You got an answer already? What's wrong, Ryan? What's wrong, man? Okay. Is that what you got, Riley? So, Jacob, does he feel heavier or lighter? Feels lighter. What if the elevator accelerated down? What if the elevator accelerated downward at negative 9.8 meters per second squared? What would he weigh then? 0. He'd be weightless. Yep. There would be no tension on the cable. Cut it. Free fall. So he would weigh how many newtons, Greenie? 0. Well, all you got to do is like in cartoon land and just step off. Open the doors. I'm not even going to draw a picture for number D. Christopher, constant speed. Constant speed, is there a net acceleration? Yes or no? So is acceleration 0 again? So is it just equal to the weight? Yep. And number E, in what direction is the net force as the elevator slows down to a stop as it's moving down? Box. Elevator's moving down, but it's trying to slow down, so what direction is the acceleration? Up. So direction is the net force. Up. Jacob, you don't like that? You okay, Jacob? Spencer, it's all right. Ross? Chase? No? Yeah. No, Greenie, there was always time for more math. Greenie, you never stop doing math. This isn't calculus, Greenie, it's algebra. All right.